So here we're showing the negative resistance of a DC to DC converter. And so I have my DC to DC converter here, and I'm connecting the AFG signal from the oscilloscope to modulate the J2121 line injector. So that's putting a small sine wave onto the input DC voltage to the DC to DC converter. The scope probe here on channel 1, that's measuring the modulated voltage. And there's a Hall effect current monitor built into the injector, and that's going into channel 5. And so the software is dividing voltage divided by current, and well, of course we know that as impedance. Then I have a DC load here that's just providing a 6 amp constant current load on the output, and I have a benchtop DC power supply that I'm using to put input voltage into the power supply. I'm going to start out, I'm going to measure this at about 14 volts to the DC to DC converter. I'm going to run that sweep, and then I'm going to reduce the voltage down to about 7 or 8 volts, and you can see how it is that it impacts the negative resistance. So let's watch this one first. Now you can see that the phase here is bouncing a little bit between plus 180 and minus 180 degrees because we're not phase unwrapped. And of course, plus 180 and minus 180 are the same point. And so all measurement instruments struggle with that unless we tell it to unwrap it and unwind it in only one direction. What we do care about is noticing that it's negative, and also we want to note the magnitude of that negative resistance. And this is about 34 dB or so, roughly in this flat range. Here we're becoming capacitive. That's the input capacitor of the module. And here's the negative resistance in that flat part there. So at 14 volts input, it's at about 34 dB ohms, or just about 30 ohms. I'm going to stop this and I'm going to rerun it again. But now I'm going to reduce the input voltage down to about 8 volts. And now you can see it's reduced to about 25 dB ohms, which is roughly 20 ohms input. So the impedance went from negative 34 ohms to negative 20 ohms as the input voltage went down. And again, you can see we're right at 180 degrees, so it's bouncing between plus and minus 180. And again, this is a really important measure for filter stability. This is the Middlebrook Criterion that says because of the negative resistance of the DC to DC converter, if we put an EMI filter that has a positive real resistance of that same magnitude, then the two will oscillate when we connect them together. So it's a very important measurement. But there you go. That's how easy it is to do it on a 6 series scope with the J2121 modulator.